So now we're going to take a look at sketching these graphs of the polynomials. And there's three key features that kind of dictate the shape of the graph. First one obviously being where are the x-intercepts at, or the zeros. And the ones we're going to focus on are the real solutions. So if it has an I in it, so a complex or an imaginary number, those are not going to show up on the graph. Second phase is the end behavior. What is the graph doing at the end points? So as x goes towards negative infinity and towards positive infinity, how is it behaving? And there's two things that are going to dictate it. Number one is whether or not the power is an odd number or an even number. So if we think back to parabolas, for example, a parabola is an x squared, so it's an even-powered function. The end behaviors are going to do the same thing on both sides. Because again, if I square a positive or if I square a negative, the answer that comes out is going to be positive. On an odd-powered function, the end behaviors do opposite things. And it's for the same reason. If I have a negative number going to an odd power, the answer comes out to be a negative number. So with an even power, it comes out to be a positive number. So the other phase is whether or not your lead term is a positive or a negative number. So here is what an even power will look like here. So if it's positive and it's even, both ends are going to go up. If it's negative and it's even, both ends are going to go down. On an odd-powered positive situation, the graph is going to finish up. That's kind of the way I think of it, so that means the other end has to be going down. If it's negative, everything is going to flip. These negative numbers are now going to become positive because I'm multiplying them by a negative number, and vice versa. So it's going to finish down if it's negative and odd. The third piece is what's classified as a multiplicity. So do we have a double or a triple root occurring here? So a double root scenario here, the graph will not pass through the x-axis. So normally on an intercept, that tells us where it crosses the x-axis, but that's also where the graph, the y values change from positive to negative. On a double root, that does not happen. So it touches the x-axis, and rather than pass through, it bounces back and stays on whatever side it was to start with here. On a triple root scenario, it does transition from negative to positive. The only detail that we have to add to that piece is at the zero, at the intercept, it flattens out right here. And the reason for that one here, so example I'm using here, let's say this is at 2. So there's an x-intercept at 2, which means there's our factor, x minus 2. If you look at numbers that are close to 2, so for example, 2.1, well, what's 2.1 minus 2? It's just 0.1. So if this thing is cubed, 0.1 is already a small number. When I cube it, the answer gets even smaller. So what happens on those scenarios is those values that are close to the intercept, that are very small, when you cube them, they become even smaller. So they hover around the x-axis a little bit longer than a normal scenario here. So those are the three things that are going to play a role. What are the real solutions? How does the end of the graph look? And do I have any double or triple roots to look at here? So the first example we're going to look at, I've already done out for you here. But here is our function. So first piece is, there it is in a factored form, what would the zeros be? So if x plus 5 is the factor, that means negative 5 is the intercept, or the zero, or the root, whatever you want to call it. If x minus 1 is the factor, that means positive 1 has to be the solution. And if x minus 4 is the factor, that means positive 4. So all three of these solutions are real, so all three of them would show up on the graph. So there is your negative 5, your positive 1, and your positive 4. The other part then is identifying the end behavior. So how many zeros do you see here? Well, there's only 3 numbers. But if we pay attention to this last factor, you see that factor being squared. which means that that x minus 4 actually shows up twice. So 4 is a double root. So that actually counts as 2. So there's 2, 3, 4 solutions. So that means this is an x to the 4th power. So it's an even-powered function. The other piece is, what is the lead coefficient? Well, the easy way to figure that out, even though it's factored, is just multiply your lead, your x terms, your variable terms here. So 1x times 1x times 1x times another 1x, because again, this one is squared, so there's 2 of them, would give me a positive 1 x to the 4th. That would be the lead term if you were to actually FOIL this thing out. So it's positive and it's even, which means the n behaviors are both going to be going up. So now, once we figured that out, it's just about transitioning from positive to negative. Now note, at 4 we have a double root. So it passes through this first 0, comes back, passes through, and then it comes here. Instead of passing through, it hits off the x-axis and stays in that positive piece here. Now, as far as the graph goes, I don't care how low you make the humps or how high you make the humps. That's not important to me. What I'm looking for is, do you have the zeros? Do you have the right n behavior? And are you accounting for any multiplicities, any double root scenarios? So these graphs are going to tend to look like W's and M's for the most part. Let's take a peek at a second example here. So here is our function. So first thing we're going to look at is this first part. So I've got x cubed. Well, if it's just x, that means 0 is one of our solutions here. X plus 3 means negative 3 is a solution. And this means positive 4. So again, all 3 zeros are real. So all 3 are going to show up on our graph. Alright, so there's my zeros. The next piece, now what is my lead coefficient? So I've got a negative 1, a positive 1, and a positive 1. So negative times a positive would be a negative 1. And now I've got x cubed times x times another x would be an x to the 5th. So again, this x cubed means 0 is a triple root. I'm going to put a TR there to signify triple root. So that one's actually counts as 3. So there's 3, 4, 5, 0. So it's negative and it is odd, which tells me my n behavior is going to be finishing down. So the n behavior of the graph is doing that piece. And now I'm going to follow the same protocol here. I'm going to pass through the x-axis here. Now at 0 I have a triple root, which means this graph is going to flatten out around 0. And again, I don't care how high and low you make those humps. What I'm looking for is, do you have the zeros? Do you have the proper n behavior? And are you accounting for any double and triple roots? So those attention to details there.